In this video lesson, we will learn about the domains of logarithm and exponent functions. So first of all, let's remember what we mean by a domain. What is meant by a domain is what values of x you can plug in and actually get a valid answer. So what this means is it's the set of all possible values of x they can plug into a formula so that it makes sense. So for example, you can't take the square root of -1, and you can't divide by 0. So these are a few limitations on domains of certain functions. But what are the limitations if you're dealing with logs and exponents? Well, we're about to find out. So let's start with just y equals 2 to the x. This is an exponent function. We can plug in x equals 0, it works, and we'll get y equals 1 because 2 to the 0 is 1. And we can also plug in x equals 100. It'll be a really big number, but it works fine. In fact, you can plug in any x, and you'll always get some sort of answer. So the domain of 2 to the x is all of the real numbers. All of them. There's no problem with taking any exponent of 2. So there's no limitations if you're using exponents. Alright, well, what happens if we turn to logs? Well, there are actually some limitations. Specifically, if we have y equals log of x, then x cannot be less than 0. In fact, x has to be strictly greater than 0. So the question is, why cannot we plug in a value of x less than 0? Why does log of -1 or -10 not exist? Even log of 0. Is there a particular reason for them not to exist? Well, let's look back to the exponents, because remember, the logarithm comes from the exponent. The way this works is, let's say we have the exponent function. It takes some values of x to some values of y. So it takes 1 to 10, 2 to 100, 3 to the 1000, all for the reasons that 10 to the first is 10, 10 to the second is 100, and 10 to the third is 1000. And the logarithm is defined as sort of the reverse arrow. We go backwards. So if we have log base 10 of 1000, we go back to 3, because 3 is the power of 10, which gives you 1000. And similarly for 110 and 2 and 1. So what does this mean in terms of the domain of the exponent? So I'm just going to make this little chart here, which is analogous to the drawing I made next to it. We have x equals 1, 2, and 3, and y equals 10, 100, and 1000. In this little table, this is for y equals 10 to the x. Alright, so first of all, when we have an exponent function, we don't make a negative base. It's just tradition that if you have an exponent function, then you're taking a positive number to some sort of xth power. The simplest case is just some positive number to the x. Why not negative numbers to the x? Because if you plug in x equals 1/2, then you get the square root of, let's say, -2 in this case. And that's not a real number. And that's not very convenient if you can't plug in x equals 1/2. So we always use a positive base. But if you have a positive base and you take it to any power, you will also get a positive number. Now here is where the limitation on log of x comes in. If log of x takes this positive number and returns the positive number, positive or negative x, then we cannot plug in a negative number. Meaning, suppose we have, let's say, log of negative 10. What this amounts to is, what is the power of 10, which gives us negative 10? So 10 to the x equals negative 10 for some x. But 10 is positive, and whatever power you take of 10, whether it be positive or negative or 0, you're always going to get a positive number. You can't get negative 10. That's why you cannot take the logarithm of any number less than or equal to 0, meaning x has to be greater than 0. So this is why this is required. And it's okay if you didn't totally get that, because as long as you remember it, it can help you find the domains of related logarithm functions. For example, let's say you have log of 2x minus 1. What is its domain? Well, we know that the inside has to be greater than 0, strictly greater than 0. So we have 2x minus 1 greater than 0, 2x greater than 1, x greater than a half. We just solve a simple linear inequality. Now we're going to draw it on the number line. It's always a good idea when you have a solution as a set to represent it on a number line. So here's a half, and since x is strictly greater than a half, we use the open circle, and then we highlight on the side that's larger than a half. We can also write it using this set notation, 1/2 to infinity with regular parenthesis, because 1/2 is not included. So this is the answer for this question. We can do another similar example. All you have to remember is that you have to take the log of a number greater than 0. It's impossible otherwise. So let's say we have log of 2 minus x. What is the domain? Well, 2 minus x is greater than 0. So negative x is greater than negative 2. And remember, when we multiply by negative 1, then we have to flip the signs. So we get x less than 2. And again, we just draw it on the number line here. We'll mark 2 with an open circle because it's strictly less than. And then we highlight the part that is less than. And finally, we just write it in set notation, negative infinity to 2 with parentheses because the endpoints are not included. And that is the answer. Well, thank you for watching this video lesson, and I hope it helped.